So in this video, we're going to introduce linear inequalities. Okay, so let's just start introducing it here. So 1 less than 3. So we read 1 is less than 3. That's how that's read. Okay, is this a true statement? Yeah, I think so. 1 is less than 3, so that is true. Okay. What about this? If I multiply both sides by -1, so I multiply, so I have 1 less than 3, and then I'm going to multiply by -1 on both sides. Now I have -1 less than -3. Is that true? No, it is not true, is it? So that's false. Okay. What would make it true? It would be true if 1 is written as greater than -3. This is a true statement. -1 greater than -3. It's better to owe somebody $1 versus owing them $3, okay? So we just learned a little trick here, all right? If I multiply the inequality by a negative, then what happens to the inequality? The inequality turns around, okay? So it goes in the opposite direction, okay? So the inequality flips when you multiply / divide by a negative number. Okay? All right, so just to make sure we know how to graph these things, say I have x is greater than 1. How would I graph this on a number line? So I would take a number line like this, and I'd put a mark at 1, and I want to put one number to the left of it, so maybe 0, and one number to the right of it, so 2 would work for that. Now, how do I graph this? What I will do is, okay, x greater than 1. So all numbers that are greater than 1, where is this true? It's true everywhere over here. Okay, so I'm going to put an arrow this way because it goes on forever and ever. Now, do we actually equal 1? No, we're strictly greater than. So what I'm going to do is I'm going to put a parenthesis right there. Now, there's a reason I put the parenthesis right there, because this represents graphing the inequality. But if I wanted to put it in interval notation, to do interval notation, okay, we read left to right. So the first thing I see is the 1, and then I go out to infinity. Now, I never touch 1, so I have this parenthesis, so I'm going to put this parenthesis right here. And guess what? Can we ever reach infinity? No, if I get to infinity, I just do infinity plus 1, right? So we can't ever get to infinity, so I put a parenthesis around the infinity too. Okay? Let's do another one. Let's do x greater than or equal to 2. Okay, so where is this true for? Well, the first thing I'm going to do, I'm going to put a line on 2. And I need to put a number to the left, so 0 is always a good one, and a number to the right, maybe 4, whatever, just some number that's bigger than it. That's all I'm looking for. So make sure you get the number and then something to the left and something to the right of it. Now, how am I going to graph this? So I graph this, I look, I say, where is x greater than or equal to 2? Well, everything to the right of 2, okay, and on and on and on forever. Now, do I actually have it equal to 2? Well, yeah, this is x is greater than or equal to the 2. Okay, why do we have or equal to? Because there's a bar, a line underneath the inequality. Okay, so it's a greater than or equal to. Okay, so that's what that bar under there tells you. It has a or equal to added to it. So now that we actually touch the 2, I'm going to put a bracket right there. And there's a reason I put the bracket, because the interval notation starts at 2 and I go out to infinity. Now I can't ever touch infinity, but I do actually include 2, so I'm going to put the bracket for 2 since it's included. So that's the difference between strictly greater than and greater than or equal to. Okay? So let's do it for the other 2. And so I've got x is less than 3. So x less than 3. So graphing it, I put a mark on 3. And I want a number bigger and a number smaller. So a number bigger might be like 4 and a number smaller might be like 2. Whatever, just pick one, right? So to graph it, I want numbers that are less than 3. So numbers that are less than 3, what's less than 3? If I got $3 in my pocket, less than 3 is like $2, $1, negative dollars, right? It goes on forever and ever this way, okay? Now, do I actually include 3? No, I don't. I don't see the bar underneath, so I don't include it, so I'm going to put my parenthesis right there. So in interval notation, I read from left to right. So what is the furthest left here? It's not infinity, but it's negative infinity. We go negative infinity all the way up to what? 3, right? And we don't include 3 and we don't include negative infinity. So that's what the interval notation looks like there. Okay? And the last scenario would be x less than or equal to, let's not use 3, let's just use 4. Okay? And so if I have 4, maybe I got 10 over here and 0 over here. Okay? So 4 less than or equal to 0. Okay, that's going to be, or less than or equal to 4. It's going to be everything less than 4. And then I have a bracket at 4, okay, because I have the bar underneath that tells me less than or equal to. Less than or equal to. Okay. All right, so interval notation would go from negative infinity up to 4, and I have a bracket on the 4 and a parentheses on the negative infinity. Okay. Now, there is a trick, all right? There's a trick to knowing which way to shade, but the trick only works when the variable, and in this case x, is first. Okay, what do I mean? So it's like x is greater than 1. The variable is first. Okay, so what is the trick? The trick is the inequality, we can turn it into an arrow and it tells us to shade to the right. Okay? All right, so in this problem here, we shaded to the right. And then maybe in this problem here, I had x less than or equal to 4. Okay, the inequality here is telling me what? It's telling me to shade to the left. Okay, so a shade to the left. Okay, and the bar underneath tells me it's a solid, and the no bar tells me it's a parentheses. Okay, so remember this trick, it only works if the variable is first. Because if you write the number first, okay, and then you have the variable, then this tells you to shade to the right, but in reality, these are numbers that are less than 4, which would be shading to the left. So the trick doesn't work when the number's written first. Okay? I kind of think of it, I mean, this is super goofy, but I think of it literally as the alligator, okay? The alligator eats the bigger number. Okay? So if you ever wonder like which one is bigger and which one's smaller, the alligator's always going to go eat the bigger one. Okay? So that's the idea. All right? So just a formal introduction to inequalities and how to graph them and then show interval notation.